The speaker needs to unmute his computer so we can hear online.
Is that better, Brian?
Yes, thank you.
So having positive command and control, it makes sure that all the clocks are right all the time. They're able to program the school schedules in, including early releases. It also makes sure that the flashers are working and keeps up with battery voltages, solar inputs. So the shop has advanced information about it. If there's one that's not working quite properly, they can go out and take care of the maintenance on it before it becomes a problem. It's a cellular system. The vendor hosts it. We just have a web browser we go into, make the changes that we need to do. It's worked out really well. The shop loves it. It was not cheap, $630,000, and we finished out putting all that system out in 2018. Emergency preemption. Plano is a city that has 100% coverage with emergency vehicle preemption across the signal system. One of the challenges with that system is in its basic configuration, which it was for ages. It's not a secure system. So somebody could go on eBay, buy an Opticom emitter, put it in their personal vehicle, their commercial vehicle, and just drive around stealing the green everywhere that they go, which creates all kinds of problems with the signal timing. So in order to stop that, we did a project to go in and upgrade the actual phase selectors or the computers that are in the cabinet for Opticom. Stood up a central management system for it, set up a secure coded database. We coordinated with all the other agencies in the region that go through Plano to get their vehicles assigned codes, and everything is unique. We know exactly what vehicle is going through the system at what time. So what we saw after initiating that was about a 20% reduction in the number of preempt calls. So we're seeing that number of reject. Which is an emitter that's not coded, which 20% is a really big number when it comes to that. It was about $300,000, and that got wrapped up in 2020. So at the intersection level, as we sit today, we use Caltrans cabinets as opposed to the NEMA style. So ours look more like a phone booth as opposed to a big square on a pedestal. We have TrafficWare, formerly NASDAQ 2070 controllers. Vivids detection pretty much everywhere. There's one intersection that still uses loops. The loop cuts are still on the pavement in a lot of areas. You can still see them. It's a good place to stop if you are at the intersection, but it's not actually the loop that's in the pavement. It's the cameras that are above. We have Ethernet communications to 100% of the system. And one of our limitations with the current system is the signal cabinets only have the ability to put out 16 different independent red, yellow, green channels, which when we get to our diamond interchanges and some of the more complex intersections, as time goes on, we'll have more right turn signals, things of that nature, and we need more. So at the intersection level, we are working on a project to replace both the cabinet and the controller. So in order to do that and get through our procurement processes, we have to develop local controller hardware and software specifications, as well as specifications for the cabinets. The controller procurement, we just finished that up, working with the COG to establish more of a regional contract that can be used by all the agencies. And the traffic cabinets, the specification for us is pretty much done. We're just working with our purchasing department to get that moving. The deployment of the controllers and the initial rollout of the cabinets will be done by city forces. And then once we get to where we're ready to start doing 220 cabinets, that's where we'll get a contractor on board to help do that work. We're hoping to be done with that whole project in 2026. So it'll be a real aggressive schedule once we get there. The signal central management system. So this is what we use in the traffic management center with the big map that shows us what's going on with all the traffic signals. We also, engineers, signal technicians, we all have access to the system, so we can all see what the signals are doing at any time. If somebody calls and says the signal's in flash, we probably know about it already just from the maps, or from the system can send emails, things of that nature. The system that we're using now, though, goes back to the beginning of the controllers. The NASDAQ system was started back in 2004. So the architecture that's underneath this system dates back that far as well. So there are a lot of features and enhancements that modern systems have that this just does not. It's the user interface is a little bit on the clunky side. It's local. The whole system is locally hosted at City Hall. Servers that are city servers.
Huh? Mm.
It does not support any sort of mobile devices other than having an internet connection actually with the technician, and then a laptop computer with them. Our new central system, we're going to completely replace that to go with our new controllers. Cloud hosted, and then controller hardware agnostic. The trafficware system only talks to other trafficware items. So sort of like the Apple ecosystem is in the computer world. So we're looking for a modern browser-based system where we can just get into Chrome from pretty much any, Safari, and be able to get to the system. And then it needs to support signal performance measures. We'll talk a little bit about that later. We need to be able to create reports that are unique to a specific situation. The current system just doesn't do that. It is a very limited number of reports that we can pull. So we're looking at about $600,000, and we're hoping to stand up this system either late this year or in 2025. Vehicle detection. So I don't know how many of you drive around the city of Plano and see from time to time a left turn will come up for no reason, a left turn will get skipped. Things just won't work right. The picture here shows an example. There's a car in the box, but the box isn't lit up. That's a problem, especially when it's a protected movement. So Vivids is great in the fact that it is out of the pavement. So if there's a pavement failure, if there's a contractor that comes through and does a pavement cut, we don't have to worry about our detection system getting taken out by that. We have to worry more about wind and hail and birds and things of that nature. Poles moving around. So historically, the system that Plano has, it tends to have issues with dropped calls, and then it has a real hard time with sun and rain glare. We get the most phone calls. There's 2 times a year, in the fall and in the spring. They go along with the equinox, where the sun gets real low on the horizon and it blinds the cameras. So then we have all kinds of issues with timing. Maintenance with a Vivid system, the lenses do tend to get dirty. It's not a real fast process. They're not going around with Windex to every signal every 3 months or anything, but it is an issue. And then Vivids, because of the sun angles, they have to point the cameras down, and we get a limited distance where the detector can actually be placed. And when we get into doing performance measures and trying to get detection at like a 500 or 600 foot range, we just simply can't get there with the current technology. So the detection system will be completely replaced. We're looking to go with a system that uses both video and radar. So the radar will give us the ability to see vehicles at distance. And also it provides a failover at the actual intersection to where if the camera and the radar don't agree with each other, the system knows that there is most likely a car there. So this will be the spec development is pretty much done. We have plans for all the intersections. The city staff, myself, and my team will be responsible for going in and doing the setup of the detection areas for the signals, and then it'll all be installed by a contractor. That's a real big project, about $8.3 million, and we're on a pretty aggressive schedule with that as well. We're looking for the end of 2026 to be up and running there. Communications. I don't know if any of you ever saw the video of the water tower up in Legacy getting knocked over. Uh, there's a problem for the signals group in that there was a wireless radio repeater up on top of that tower. That repeater did not get replaced. It just went away. So the map that's there shows kind of the colored dots show what signals were talking to which one of the towers. The purple ones were talking to the one on top of the water tower. So when that went down, we tried to repoint and kind of get all the signals, but we didn't have it. We went to a cellular approach to basically take down the old wireless and move into an Ethernet-based communications network. The city at the time also had a Wi-Fi mesh network, which picked up some of the other signals. The technology department came up with a fiber optic project to go around and get all the facilities in the city connected via fiber rather than the wireless system. When they did that, transportation worked with technology services to have them just make a stop at each one of the signals as they went along that were along their route. So that's the map that you see there in the center. They picked up about 109 signals, I believe, with that first round. So we still have 130-ish that still need to be connected. And recently, technology services did a refresh on our modems and got us into 5G. So we got a little bit better bandwidth, and considerably better connection qualities. So there's another phase of the fiber project that is pretty much all transportation, and that's going to extend the fiber network around the city to pick up the vast remainder of the signals. There'll still be a few that are kind of off the fiber grid, and it's just locations where it just does not make economic sense to take a fiber line out to that distance to pick up one traffic signal. So this PS&E is currently in progress. There'll be a contractor installing all of it, and that's about $4.9 million for that project. We're looking at 2027. Material availability is a big challenge for that project. Getting a hold of the actual fiber cable, that's a big piece of where that 2027 date comes in. CCTV. So we will have, through the new detection system, the ability to bring the video feeds from the detection system back, which will give us views of all the approaches. And then the pan-tilt zoom PTZ network gives us the ability to look at various areas around the intersection, see the actual intersection platform. There's some possibilities for doing some AI-based tracking for near misses, things of that nature, to enhance our ability for safety purposes. We're looking to get PTZs at about 90% of the intersections. The current project picks up 80 of them, I believe, or 160 of them. There's a following project that's city funded that is another 80, which gets us pretty close to having everything covered. $3.3 million, and we're looking for the end of 2026 for having all those cameras. So performance measurement. So once we get the new central system stood up, that'll give us the ability to start pulling real-time data from the controllers, which is, we'll know how many cars went through the intersection at what time relative to red, yellow, and green. It gives us the ability to make real-time timing adjustments based on actual traffic volumes. So if we have something that happens, something big maybe that's permanent, like they build a Walmart right near a signal, we would be able to see that the demand went up and make an adjustment. During the middle of the day for schools, if we have a big swing in traffic volumes, like what COVID did, where we've seen very different traffic patterns to where we don't have the amount of traffic that's right in the middle of the AM peak hour going over to the legacy area. It's more spread out. The afternoons are very similar. So in order for us to track along with that in the traditional way, we have to wait until we take intersection traffic counts, which is every 2 years, and then take those traffic counts and develop new timings off of them, and then implement that citywide. So we're looking at probably 4 years before we can react to a change in traffic patterns. Whereas if we have performance measurements that are telling us how many cars are going through, we can look at how much dead green there is and just move that time around, and that can happen in a matter of days or weeks. So we'll be able to respond much quicker. So for the performance measurement systems, the specifications will come from the consultant, and that'll kind of dovetail on the central system project. About $1.2 million for that. Completion would be pretty much contingent and parallel with the new central system. So what kind of metrics does that give us? So the chart that's shown here is very traffic engineer. I don't expect you guys to understand it completely, but where you see the stair steps and all the red, that's vehicles that are arriving at the signal when it is red. And the goal is to get that green to be a nice smooth band to where the majority of vehicles do not stop. So that's in a nutshell what that system gives us the ability to do, to visualize the coordination. And then also it gives us the ability to see pedestrian actuations when pedestrians are using the signal. So if we see like around a school, you would see very, very active pedestrians then and then not during other times of the day. We can take advantage of the times when there are not pedestrians to give more to the vehicles. And then during the times of day where there are pedestrians, we can make accommodations so that the signals stay in step with all of the neighbors. And if we don't do that, then the signals kind of get out of step, and then you wind up getting more stops. And in a school zone, it just encourages bad behavior. The other thing it gives us the ability to do is we will be able to tell based on what color the signal is and when cars go across certain detectors, when people are running red lights. It's not for an enforcement, it's for safety purposes. So we'll know where those locations are, and we can increase the all red time. We can also give the police department a call and let them know, okay, for this month, here's the top 10 locations where people are doing this. And they can go out and do very targeted enforcement instead of just trying to wait at a random signal. So pretty much this is everything that we just talked about. And then the final piece of it, and Mr. Palmer that's sitting in the back, data collection. So like I said, every 2 years we do a big citywide project where we go around and we count everything, all the roadways. We do a traffic flow map. Any of you that have worked in Plano on a development project are probably familiar with that map. And then we count all the intersections. The intersection volumes go into the signal retiming project that we do, which is generally every 4 years. But that gives us the ability to look at trends and figure out where we have too much green, where we don't have enough, and go around, make adjustments and make things more fair. We try to get things as efficient as we possibly can. We're still north-south in the mornings tend to be the heavier and in the evenings. But with Legacy, we've seen a lot of east-west. So we have to go in and make adjustments to make it fair so that north-south doesn't get a free pass and east and west sit through 6 cycles in order to make it across Custer. But the data collection, it'll come off of the detection system. So we'll be able to count cars, individual vehicles off of that system, which gives us the ability to possibly bring down the amount of actual count data that we're collecting in the field, and then we can reallocate that money to some sort of other system that gives us more holistic data, big data type of stuff, that shows us congestion levels and gives us dashboards that show us by day of week, by month, so we can start tailoring special timing plans for certain things. It also helps with incidents. We can go back and we can look at, okay, there was this crash in this place, and what did that do to traffic, and what could we do to help people get around that? And then special events. The Balloon Festival right now is the biggest one, and a lot of the signals pretty much do the normal thing that they do, and the ones that are right around the event, the police go out and just kind of put the signal and flash and direct traffic. So having all these systems would give us the ability to take a little bit of that away and keep the intersection under signal control, rather than relying on PD to go out there and stand in the middle of the intersection, which they don't like. So funding sources. So with all the projects, we're looking at just shy of $30 million in CIP city bond funds. The capital maintenance fund, which is really more along the lines of the general fund, $9.8 million from that. And then CMAQ money, congestion management from the COG, 2.3 there. And then 1.4 million from the red light running funds. The TMC is the last project that we got funded out of that. So that last $450,000, because they're looking to sunset that. The cameras went away, 3 years ago? So there's still money in those funds. I think overall transportation probably used somewhere in the $5 million range. We built a bunch of new signals. We did signal timing plans. We upgraded some equipment. We put in the school flashers and built the TMC. All that for $75 a pop. And the city would get half of that basically. So $43 million. So here's a photo of our group. Brian Shusky, who was on the call and told me that the mic wasn't working, is the city traffic engineer, also known as the transportation engineering manager. And then myself, if you have any questions or want to reach out and talk about traffic, we also do offer, we can provide tours of the traffic management center. If you're interested in coming out, bringing young engineers out to see how this all works, we are definitely there to show and tell. Any questions?
There seems to be a goal to remove the sensors from under the pavements because of damage, construction, pavement movement.
Right.
There also seems to be a goal to put in fiber optic to the same infrastructure. Is it not as susceptible to damage from the same events?
It is not. Generally, the fiber optic is either, if it's underground, it's going to be in the shoulder or the parkway, under the sidewalk. Some of it uses the conduits that are already in place for the traffic signal. And then there is a large portion of the fiber network that's aerial, similar to what Spectrum or Verizon have, where they're just attached to the Encore or CoServe poles. So the system is very robust, but yes, there is still the concern that somebody's going to come out with a post hole digger and punch a hole in the fiber. And it happens. The network is built primarily as rings that are redundant. So if we do have a break in one place, the data can go around the other direction. And since it's moving at the speed of light, we don't really see a degradation in the speed. But Technology Services is sensitive to us taking a section of fiber out of service for any particular length of time, like for an intersection project. If we're putting in new conduit, they don't want us to come in and take out the fiber and not come up with a temporary means of making that connection. Because if we take out one link and then something happens that's more of an emergency on another piece of it, then you have a break. And since it's not just traffic signals that are connected to it, it's city facilities. So you might lose the emergency operations center, you might lose a fire station, not desirable things. And they're not the types of places where you can just put a cellular modem in and say, here's your network connection, because they don't have anywhere near enough bandwidth at that point.
Is this fiber optic, is that your own dedicated infrastructure?
Yes.
Or it's not part of the phone system?
No, that's 100% city, with the exception there are a few places where we will be utilizing TxDOT or Collin County or PISD if they have infrastructure in the ground and they have fiber optic strands that are available that are dark for them. There are opportunities for us to connect to those dark strands and utilize those to get through some difficult areas, like along the tollway. NTTA has very limited right of way that's left to be able to go in there and start putting in conduits. The other areas that are challenging are railroads. It takes forever to get the permits, and then it takes forever to actually build the stuff because railroad construction is so tightly regulated.
So I live in Harrison and spent a lot of time in Plano. What I've noticed is when you saw some of the paper plates flying through a red light, do you know what the camera frequency is working measurement?
So currently, the majority of the system is analog. So the only place that video goes is into the signal cabinet. There's a computer in there. The technicians will look at the video if there's a problem, and they'll go in and they'll reprogram. There's about 40 intersections presently that are modern, that utilize digital technology, that we do have the video streams coming back to the traffic management center. And that's a continual feed. The city of Plano records, and this is a citywide policy for all the cameras other than jail. They record and maintain video for 7 days. So if there is a particular event that PP is interested in, they can go in and they can pull that data. The video detection systems really aren't of a resolution that it would give you a plate number per se, but the fact that if they go in and they watch and it's like, okay, Monday, that car ran the red light. Tuesday, that car ran the red light. okay, they're going to go sit out there on Wednesday and they're going to hopefully find that guy.
Yeah, my question is more, let's say this is a pattern and how you identify that pattern with your camera, like the frequency of the measurements, like is 10 frames per second, 40 frames per second. If someone's going like 90 to an intersection, can it catch it?
It doesn't catch it automatically, but if there is something that happens that we go in and we dig into an intersection for a specific thing, there was a traffic crash last year where there was a Lamborghini that was involved in this wreck. And we were really curious about, because he came into the frame, he came into the view and was crashed like that. But it wound up being, I think he was in frame he was in the camera's view for 2 frames. So we went through and similar to that, went through and did the calculations to figure out, wow, he was doing about 120 miles an hour. So we do have the ability now. The AI systems with the new PTZs, once we have those cameras where they don't have to pan around all the time. Right now they do a tour so we can see all the approaches. The new detection system will give us the view of all 4 approaches to where we don't have to do that. And once the camera can just fix on the center of the intersection, it'll be watching for things like near misses or speeds that are in excess of, and then it would be able to send an email or forward a message along to whoever may be interested in that. The police department obviously is really interested in these types of things.
One more question. This is a quick one. You mentioned that your traffic management system incorporated Waze somehow at your office.
Right.
Does it at all send any feedback to people using Waze? For example, like you have the flasher system for school zones. Does the app for whoever's driving, does it tell them, hey, you're about to hit a school zone?
As of the moment, it does not. But that is one of those looking forward things that could be done. I don't know that Waze currently supports that type of functionality, but if they did, we would certainly be able to provide them with GPS coordinates in the schedule. And since we are in that program, anything that comes from the city of Plano that goes to Waze pretty much goes instantly to the map because we're a verified contributor. What they do ask for presently is full road closure information. We generally don't go in and put in, there's going to be a spectrum utility crew out between here and here, and the right lane is going to be closed. But when it does come to construction, if there's a full closure that's going on, we do put those in. If there are special events, we can put that in. And then if there are incidents, we had one a couple years ago where there was a gas line that was hit off of Independence, and Atmos came in and the fire department closed off a big chunk of the arterial. So we were able to go into Waze and put that information in there to help people not go that way. Yeah.
One of the other reasons you talked about upgrading the system was for unauthorized users. Have we all had instances of people trying to hack into the Signal program or kind of almost turn on the live screen for themselves like a Bruce Almighty moment? Or is it also like trying to neutralize it right before it can potentially come on?
So the security that we put in for the Opticom system, that system is infrared. The emitter can put out a code. Previously, it just put out the default code, which is where the unsecured piece of it came from. But since we've gone in and coded all of the vehicles, now the system has to see that code and then it will authorize the preempt. In terms of hacking the central system or the intersection control, we do not use Wi-Fi at the intersection level. The controllers do have Wi-Fi and Bluetooth capabilities. Those are turned off. So at the actual signal, that's somebody would have to physically plug an Ethernet cable in order to do that. And the technology services department has locked that down to the point where they would have access to the city's guest network. So they're all VLAN off. In terms of the Signal Central system, that's all part of the specification development. Again, technology services is very heavily involved in the security that goes along with that. But at the very end of the whole situation, the Italian job where they had all the green lights getting turned on, that's really not possible. There is a piece of equipment in the cabinet called the conflict monitoring unit, which is programmed to not allow conflicting movements at the same time. So if we try to do east and north, the signal just goes into red flash. which requires a signal technician to go out and reset. So, yes.
Does any of the systems use artificial intelligence?
Yes and no. So if you think about the video detection system, it's looking at an image, and this has been going on since the 90s, when Vivids was introduced. It's watching an image that's coming off the camera. We've defined an area that it's to watch, and it knows within this box, if I see pixels move around, I turn the box green and that does something. So very rudimentary. We can go all the way up to, like I mentioned, with the PTZ cameras, where the camera can be watching for near misses. It can be watching for even if the resolution's good enough, PD's really interested in, it can be watching for certain license plates, or it can be watching for a certain color of a certain type of vehicle. And just depending on what the AI is that's behind that system, the sky's the limit with what you could do with it. The detection systems you saw in that slide. So this is an example of one of the intersections that we do have the ability to see the detection information at the traffic management center. The technicians can also see this on their laptops remotely. So if one of the cameras moves, if it points down, if it points left or right, the detection zones are in the wrong place. So this system is all fixed. It's based on the images where it is and the boxes are where they are. And if anything moves, it doesn't know. The pixels are just different. So AI-based detection systems take that a step, and they learn where the traffic flow is relative to the road. And if the camera moves and they pick up that traffic flow is in a different place, they will adjust and they will base the detection areas on where the traffic is rather than just where the image is. So that'll make maintenance a little bit easier. And it means we'll get a little bit more time before the camera gets far enough to where we lose a lane somewhere. We do have a couple of signals that are very prone to the cameras moving around. Up at headquarters in Spring Creek, leading into Grandscape and Nebraska Furniture Mart. It's up on top of a hill. There's a lot of wind and the poles are powder coated. So those poles get bouncing around, and the powder coating is slippery relative to the nuts and bolts, and those poles just rotate. Yes.
Do you collect before and after information on your hotspot improvements for crash safety improvement?
We do. We have a large number of intersection improvement projects that are either currently underway, recently completed. So we're watching the intersection by intersection, the crash counts. So we'll pay specific attention to locations where changes were made to identify, okay, did we have a positive impact on safety? Do we make a change that maybe people weren't expecting, or something, just something being different? We have a spike in crashes. So yes. All right. Thanks, everybody.